This is the UV spectrum of porphyrin, and it has two important absorption regions, the Soret band and the Q bands. The Soret band is also called as B band, and it appears in the near ultraviolet region around 400 to 450 nanometers, and the Q band appear in the visible region between 500 and 650 nanometer. Both the Soret bands and the Q bands arise from pi to pi star electronic transitions. As we can see, the Soret band is very sharp and intense, but the Q band is less intense and broader. The Soret band is particularly useful for the identification of porphyrins, but the Q bands are highly sensitive to chemical environment and metal coordination. When a porphyrin ring coordinates with a metal ion, the number and the intensity of the Q bands may change. Therefore, UV visible spectroscopy is one of the most important technique for the identification and the characterization of porphyrins and metalloporphyrins. Now let us see the IR spectrum of porphyrins. In the IR spectrum of porphyrin, we get a NH stretching band around 3300 to 3400 inverse centimeter, and we also get one more OH stretching band around 3200 to 3400 inverse centimeter. But this is due to the absorbed moisture. The NH stretching band occurs very close to the OH stretching band, and as a result, the NH and the OH absorption bands often overlap with each other, making it very difficult to distinguish between each other. Therefore, IR spectroscopy alone cannot be used for the identification of porphyrins, but other spectroscopic techniques like UV visible spectroscopy and NMR spectroscopy are generally preferred.